Hello, everybody. This is covering some of the content as well as some of the frameworks from the prologue in the Diamond chapter prologue. All right, so we need to do some definitions. The first is, what is a resource? Because this class is talking about natural resources. So a resource is a source or supply from which a benefit is produced, and it has some utility to someone like humans, as well as others in the biosphere. We'll talk about what the biosphere is in a little bit as well. So it's kind of anything. Humans are a resource. Water is a resource. A lake is a resource. The sun is a resource. Now, we usually break this down into renewable and non-renewable resources. So whether or not something is renewable is whether or not it can be readily replaced by natural means on an equal level to its consumption, right? So the sun is a renewable resource. It comes down from the star. That's what the sun is. The sun is a star and can be used every day as long as it's not so overcast you can't get access to the sun, or we haven't had giant volcanic eruption that's blocking the sun, or a meteor hasn't hit the earth and blocked the sun. Every day the sun shines on the earth in about the same amounts, and depending upon where you are, the days shift in length, right? At the poles, they're more extreme, but you get the same amount of sun hitting the earth on a regular basis. Oxygen is another resource, and we produce oxygen at about the same rate. Biomass is any biological materials that can be renewable. We can renew at the same rate if we're conscientious about our consumption. So a non-renewable resource is a resource that can't be readily replaced, equal to its consumption. Coal takes millions of years to be produced. Natural gas takes millions of years to be produced. They're not going to renew at a rate at which we can replace them at the rate that we're using. So these are not renewable resources. Any type of, often rocks and things like that are not considered non-renewable resources because they just don't reproduce themselves as quickly as humans are currently consuming them. So the types of resources humans need, right? Like there's want and there's need. Humans have to have water. Like no water, no life. Water is life. There's a saying from the No Dapple protest: water is life. Yep, water is life. And if you don't have water, you can't have life. Certainly not human life. Because not only do the human body needs water, our food sources need water. So water is two parts, right? We need it for our food, we need it for ourselves. And of course, air, you don't make it very long, you only make it a few minutes if you can hold your breath that long without air. So that's the balance of the gases that are mixed in our atmosphere. Humans do best when they have shelter, some way to get out of the elements. We have not evolved, we've evolved to need shelter, right? We don't have thick hair that'll keep us warm in the winter. We don't have those types of bodies that allow us to keep ourselves okay. We need shelter. And usually we need some sort of fire. So humans evolved with fire. There's actually a class that we offer here called Fire in Society that spends a chunk of time talking about how humans and evolved around fire. Once humans had control over the ability to create fire, we really started to evolve with that. Like our gut really requires us to cook our meat. The upside of cooking our meat is that we're able to process that protein a lot quicker, which allowed our brains to evolve in different ways. And so fire is a critical resource for us. Now, I say that because we need to use fire, but fire can also be like a threat to us, right? So can wind and bad food and tsunamis. So all of these resources can also turn on us. Now, our core needs come from various systems in the Earth. So we usually talk about the hydrosphere, which is water, the geosphere, which is Earth, the atmosphere, which is air, the biosphere, which is living matter, and the anthrosphere, that's humans. We're our own sphere. That's how important we are. And we're going to talk a little bit about each of these real quick. So the hydrosphere, this is our water cycle. This is something from the 5th grade. Like, you should remember the hydrosphere, right? So there's about 1,386 million cubic kilometers of water on Earth. It's a pretty stable amount of water. Now, where that water is really depends upon whether it's frozen, is it in the ocean, is it a freshwater resource? There's only about 2.5% of all the water on Earth that's freshwater. And a declining amount of it, unfortunately, is in the form of ice and snow. That number we've estimated about 68%, although again, we are melting that ice at an extreme rate, so that may be going down. And there's a great video that I have a link to here that is actually on the Canvas course shell that I'm going to want you to watch on how heat impacts the hydrosphere, right? So this is going to talk about what it does, why it's important for us to consider the impact of heat on the hydrosphere. It's going to have, heat on the hydrosphere has helped with the droughts that we're having in California and the increase in the monsoon, the increased severity of the monsoons in Southeast Asia. It's impacting the melting of the ice caps. So humans are impacting our hydrosphere. Then we have the geosphere. So this is the portion of the Earth that includes rocks and minerals. This is a big part of what we're interested in, and we use a lot of it. It's all the Earth. It starts at the ground and goes to the core of the Earth. We're most interested in the outer part because that's the part that we really have access to. That's where we find most of the things that we use, both the topsoil as well as coal, minerals, things along that. The distribution of mountains, positions of continents, the shape of the seafloor, the location of all of the major rivers and everything like that, that's all part of the geosphere. So tectonic plate movement, subduction, how rivers actually erode the geosphere is really important to us as well. The other part of it is the distribution of resources within the geosphere is really important. So we have, at least in the last couple hundred years, really become invested in the resources found in the geosphere. As we've begun to understand how to utilize these minerals in certain ways, they've become even more important, particularly as technology has evolved. So of course, we'll talk quite a bit around oil and gas deposits as a primary resource that non-renewable resource humans are interested in. But there's also a lot of minerals and metal ores that we're very interested in. Most of the things that are around you have a heavy origin from the geosphere. So you're probably watching this on a computer or a cell phone, and in that computer or cell phone is going to be rare earth minerals. Countries that have deposits of these rare earth minerals have the ability to make money off of them if they can get access to them. One of the biggest barriers for the geosphere is how we can access a lot of the elements and resources in the geosphere. And then, of course, most of the things that come from the geosphere we don't consider as a renewable resource because they take millions of years to create. And it takes a minute or two to burn a piece of coal and takes millions of years to create it. We're not seeing a balance of its ability to reproduce itself at a rate that we're able to consume it. So then there's the atmosphere. And I have a great video about the history of our atmosphere. It's fascinating how it evolved. Our atmosphere is unique and special among the planets in our solar system. And it's looking like, there are other planets that have similar atmospheres of ours in other solar systems, but we, of course, don't have access to those. The atmosphere are the layers of gas that are held in place by the gravity of our planet. And of course, it starts here in our troposphere and goes all the way up to an exosphere, right? The thermosphere is where we have the space station and a bajillion pieces of space junk, which is actually starting to be a real problem for us because we have a lot of space junk and satellites and stuff like that up there that come crashing down to Earth. So the troposphere is where we are, and this is where life is. We talk about the ozone layer. We've done some gnarly things to the ozone layer historically. Fortunately, we realized that we probably want to keep the ozone layers, so we made some changes in our resource use to things that don't kill off the ozone layer. The ozone layer is really important to make sure that a lot of the harmful rays from the sun don't get down to us. So the Earth's atmosphere is composed mostly of nitrogen. People don't realize that. It's mostly nitrogen, about 78%, 21% oxygen, about just under 1% of argon, and carbon dioxide. Although I will tell you those carbon dioxide rates are increasing a lot because of us. We are also starting to see other greenhouse gases being released into the atmosphere. Greenhouse gases are methane, nitrogen oxide, things along those lines that actually trap heat. So we get rays from the sun that come in and help keep our planet warm, and then the ones that can get outdo. And when we add more methane, carbon dioxide, nitrous oxide into the troposphere, that heat gets trapped in, and that's how global warming has occurred. And that's how climate change is warming. I don't like to use the word global warming. I like to use the term climate change because, yes, the planet's getting warmer, but it's changing the climate that we're in. And that's happening here in the atmosphere. So then we have the biosphere, also known as the ecosphere. This is where the creatures are, right? This is the zone of life. As you get deeper into the geosphere, we don't have as much life. Like we'll have a lecture on soils when we'll talk about some of the primary layers of the geosphere. And after a certain point, it's just kind of rocks. We saw life on Earth starting about 3.5 billion years ago. So that's a while ago. And of course, through evolutionary processes, we get to what life looks like today. Now, it's important to point out that there has been 5 mass extinctions that we can detect through archaeology and paleoecology and paleontology and a whole bunch of these studies of the Earth and the creatures of the past. We know that there's 5 of them. Of course, the one everybody knows about is where the dinosaurs got killed because reasons, namely a rock fallen from the sky, but there was also some indications that there was a big disease outbreak that contributed to that, and all the dinosaurs died off, like dramatically. But there's 4 other ones that we know for sure where we see all of this life in the geologic history and then gaps, like just they're gone. There is some really interesting literature that is pointing today to the fact that we are now part of the 6th mass extinction. And this is the anthro extinction. This is the extinction from humans. Humans are causing this extinction through our choices. And we have a video that I want you to watch on the 6th mass extinction. If this is something you're interested in, there's a really great book called The 6th Mass Extinction. Highly recommend you read it. It's a fascinating dive into the other extinction events and how we can draw parallels between those extinction events and the one that we're starting to see now, as well as it helps define what is an extinction event and why is it important for us to know about that. And then, of course, there's the anthosphere, the balance of population to resources, specifically humans, the balance of the human population to resources. And we are actually going to have a whole lecture on populations and why population is important for us to understand. We can support the population that is on Earth if we change the ways that we live. So later on in the semester, we're going to talk about first world developing and third world countries. We're not going to use those terms, but those are the terms you're most familiar with. And how, first world problems are, our computers break and we need new ones, or we need a new iPhone. And developing countries' problems are we can't eat. We don't have cars to drive around. We're not contributing to what we're experiencing. Kind of that imbalance between resource use and populations across the globe, and how that resource use comes from a series of decisions that we make about how we live and how we engage with our resources. So we'll continue to talk about that throughout the course of the semester. And it's really critical to understand resource use in populations as a balancing factor in how well Earth is doing. So then we can talk about, why do societies collapse? So we're going to spend the first part of this class studying societies that have collapsed. So these are ancient societies. They're not still here with us. They're part of the past. So we're going to look at what happened to them. What decisions did they make? What does that look at like? And how did it impact them? So we talk about 7 original ways that societies collapsed. And Diamond's book is going to spend a lot of time talking about that. There's some of this also in Montgomery's book. He's going to talk about Greece and Egypt and their decision makings around agriculture and resource use that are going to impact houses. So the 3 that I think really go together are habitat destruction, soil problems, and water management problems. How we choose to live in the habitats in which we exist in their original way impacts soil and water and food access, especially for hunting and fishing. When we live in balance with the habitats we're in, we don't have problems necessarily with soil and water and overhunting and fishing. When we start to live out of balance, that's when we see these things come into play. And I will tell you that how we treat our soil is huge. We're actually going to have a lecture on soils, why they're important, how we need to be thinking about them. Soils are really, the health of the soil is really important in thinking through water retention and the hydrological cycles that come into a place. When we get too parched out, when we've cut down a lot of trees or things have burned out, things dry out, then we don't have the same access to the hydrological system as we do when things are in balance as well. And California is a great example of this. We see a lot more carbon dioxide and methane going into the air. This has created shifts in our rain and our precipitation cycles. And it's also creating increased heat, which is causing a lot of trees to die off, which is causing the soils to dry out. And that means when it rains, rather than the water going into streams and creeks and lakes and all the dams that we have for the reservoirs, the soil's sucking it up. The soil's trying to rehydrate itself because it's dried out. This has shifted how we can access the hydrological systems. This is not new. When we study the Anasazi, when we study some of the Aztecs, this is problems that they had. They began to clear habitat and the soil was not good for planting, and that caused shifts in the soil productivity and water access, and it becomes a rinse and repeat sort of cycle. We also know that when you overhunt and overfish areas, that has an impact as well. A lot of environmental systems developed with a certain population of grazers and insects and fungi and aquatic species. And when those become out of balance, that also impacts the environment around them, right? So we're all connected. When we think through all of this, I want you to think in terms of the ecological web, and how we are all connected in this process. And of course, when native species are vulnerable, or when invasive species are able to make their way to an area, if they can outcompete, they will wipe out the native species. We have seen humans do this in quite a few places, but the one that comes to mind most is Australia, where they brought in rabbits and the rabbits got out and bred like rabbits. And then they brought in cats to kill the rabbits, and then the cats got wild. And then now they've got this huge rabbit population and this huge feral cat population. And they brought in toads to do this other type of breeding. And now they have a huge toad problem, because none of these species actually evolved in this place, and none of them have natural predators. And so they're able to just get out of control and destroy an ecosystem because there's too many of them. They can outcompete the species that are there. They're not eating certain types of things and eating other things that the native species didn't eat, and that shifts the whole ecosystem. And of course, human population growth can have a huge factor. When you see an explosion in human population, they tend to expand out into less viable areas for agriculture. And that actually impacts the whole ecosystem too. And when you can't grow your food, you starve to death. And part of this becomes a per capita impact. So how much impact does it have on everyone? And it's never equal. So the new ones, so these are all traditional ones of ecocide that you're going to see when you look at your ancient civilizations. The new ones that we're starting to see come into play are human-caused climate change. We will be talking about this a lot in this class. Human-caused climate change is something we're experiencing now. When I was young, it was something, oh, it's going to happen in 2100 down the road. Nope, sorry, here now. We're experiencing human-caused climate change immediately. There's also a buildup of our environment that's having more severe effects than a lot of people recognize. Our environment has become a lot more toxic because we have polluted it. It wasn't like this before we started engaging in a lot of industry and a lot of pollution. And for instance, we're going to watch a video on plastics, and we know that plastics are everywhere. There are microplastics in your body right now. We know that kids that were born in the last 50, 60 years have a toxic load at birth. And so when you start off with a more toxic load, you're more likely to have health issues as time goes on. You're being exposed to more and more toxins across the life course. So the odds of you having health problems like cancers increase. We have also become an incredibly energy dependent society globally. So our need for energy is huge, and and if all of a sudden we lost all of our energy, we literally would decline in terms of our population. And of course, we are fully utilizing the photosynthesis capacity. I don't know why I can't say that word in this lecture, but I can. Which means that we are exploiting the entire photosynthesis capacity for ourselves, as opposed to allowing for it to be divided across the ecosystem. And so what we see happen, and this is actually in the Diamond book as well, in the prologue, we can see how a number of these things play out in terms of environmental degradation. We see population clusters together. This increases demands for goods and resources. It overshoots the natural resources, loss of resources, right? You can see how these sorts of things play out. How well a society can actually deal with these 5 specific problems impact its survivability. So how well you get along with your neighbors is really important. Our relationship with Canada and Mexico are some of the most important relationships the United States can have. Um, it's around our security, access to resources. I mean, like, people don't realize that Canada's our number one trading partner. 50% of all of our trade goes across the Canadian border. Like half of all of our goods go across the Canadian border. That's how important they are. So having a friendly neighbor is really important. Well, if your friends start to turn on you, it can weaken your trade, your economic infrastructure. That can make you more vulnerable to invasion, and that increases the vulnerability to collapse. Also, if you have a hostile neighbor, right? Increasing aggression and conflict could increase access for competition of goods and resources, as well as friendly neighbors. And that can weaken your defensive capacity. If you can't trade well and to get a balance of the goods and resources you need, it makes you much more vulnerable to invasion or collapsing from outside forces. So you can see how these all kind of go together to think through our framework of why societies collapse. And so again, climate change is a huge vulnerability that we are going to be facing globally today, and it's going to have a lot of impacts on nations in ways that people don't even think about. Our access, I'm going to use the current Ukrainian crisis. So Ukraine and Russia grow about 25% of the world's wheat and barley. That is a lot. And there are a lot of countries very dependent on that wheat and barley trade in order to be able to feed their populations. A lot of countries in the Middle East buy almost all of their wheat and barley and other cereal grains from Russia and Ukraine because they're no longer capable of growing those grains themselves, or their populations have gotten large enough where they just can't anymore. So this conflict, in addition to having immediate impacts in Ukraine, is actually going to create huge impacts on the rest of the world. And part of those impacts is that these countries aren't capable of growing the food like they used to because of climate shifts. They've seen a decline in their hydrological systems and their soil systems, and they're not, whereas these countries used to be like the cradle of agriculture and where civilizations evolve, they're becoming more and more desert. They're not capable of continuing to grow enough food to deal with their population because they don't have water. That shift in water levels has a lot to do with climate change. We in the United States are already facing some of these issues. When we talk about sea level rise, Miami is flooding on a pretty regular basis. Every time there's a high tide, they have sunny day flooding. It's not because the storm's coming in. Downtown Miami is under, half a foot of water because the tides are higher now. So this has real implications into how we are able to deal with things. So that's the end of this lecture. I had a number of video links. Those video links are all in the Canvas shell. Please make sure you watch those videos. They're really important to understanding more broadly what we're doing and how these components fit together. That ends the lecture for today.